Welcome back to the deep dive. Today we are plunging into the icy, complex world of a creature that carries perhaps the greatest identity crisis in the entire animal kingdom.
Ah, you must be talking about the orca.
Exactly. The largest member of the oceanic dolphin family, a sleek, black and white torpedo of intelligence, known by two, well, radically different names, the powerful and graceful orca.
And the notorious, almost mythological killer whale.
Yeah. That duality, it really frames the mission of this deep dive for you, our listener, doesn't it?
It really does, because for centuries, this creature was feared. Pliny the Elder famously called it an enormous mass of savage flesh. Not exactly flattering.
No, not at all. But today we've pulled together a pretty comprehensive stack of sources that, well, they reposition it completely as a beacon of animal culture, astonishing intelligence, and really complex social structure.
Right, our mission here is to cut through that, historical fear pretty quickly.
We need to understand what elevates this apex predator, which can reach, what, a formidable 8 meters long and weigh over 6 tons for the males.
Yeah, huge animals.
Huge. What elevates them from just a simple killer to the subject of intense scientific scrutiny, conservation emergency, and, frankly, global public fascination.
Yeah, and we'll be digging into everything. Their complex civilizations, these specialized hunting methods they have.
Their conservation struggles, which are significant, and believe it or not, their increasingly complicated, almost, well, antagonistic relationship with human sailors these days.
That's a really recent and strange development. But first, we really have to unpack the name game itself. Why this split? Killer whale. It's the traditional kind of terrifying label, right?
Right, and it tells us more about the observers than the observed, doesn't it?
Absolutely. That name is purely historical. It came from ancient sailors seeing them hunt the really big whales, sperm whales, baleen whales.
So it wasn't whales that killed, but killers of whales. They called them whale killers first, apparently.
Exactly, which then sort of morphed into killer whales. It makes sense when you see it that way.
But the shift toward orca, that feels significant. Where does that come from?
It comes from their Latin genus, Orcinus orca. Orcinus seems to refer to Orcus, the Roman god of the dead, the underworld. So maybe a link to their predatory nature there.
Okay, that still sounds a bit ominous.
It does, yeah. But the root orca itself, well, the sources say it's sometimes traced back to a different Latin word, meaning something like a large-bellied pot.
Slight laugh. Okay, that definitely doesn't fit the image of this streamlined 8-meter predator, a pot.
Not really, no. But since around the 1960s, scientists and the public have increasingly adopted orca. It helps recognize their true taxonomic home.
Beaches.
They're dolphins, the largest member of the oceanic dolphin family, Delphinidae.
Right. Not actually whales in the same way a humpback is a whale.
Correct. And you still hear older terms sometimes, like blackfish or grampus. But grampus is confusing because, well, Gramps is also the genus for Risso's dolphin.
Okay, so orca avoids that confusion too.
It does. And fundamentally, that shift to orca reflects a much greater appreciation for the creature's intelligence, its social complexity, rather than just focusing on its, predatory skill.
Speaking of complexity, let's dive into the taxonomy, because this is where that identity crisis gets, well, deeply scientific. We call them Orcinus orca globally, right? Implying one single species.
Yeah. But the sources make it crystal clear that classification is rapidly falling apart under scrutiny.
How so?
Well, it's what you might call the single species paradox. Right now, orca is the only recognized species in its genus. But the genetic evidence, the ecological evidence, it's overwhelming. This classification just isn't enough.
So what are scientists proposing?
They're proposing dividing the global population into multiple races, subspecies, or maybe even distinct species. Based on their specialized diets, their unique cultures, they're essentially reproductively isolated groups.
Meaning they don't interbreed?
Generally, no, which is a huge signal for speciation, for becoming separate species.
Okay, but if they look, broadly similar, black and white, big fin, why does it matter scientifically if we call them one species or 5? What's the real-world impact?
Oh, it matters hugely for conservation. Massively. That's why the IUCN, the International Union for Conservation of Nature, lists the orca globally as data deficient.
I always assumed data deficient meant we just didn't know enough about them.
In this case, it's more complicated.
Yeah.
That status exists precisely because these populations are so distinct, genetically and ecologically. If the IUCN were to officially split or Orca into, say, 5 or 6 different species globally.
Then what happens?
Then several of those smaller localized populations would immediately qualify as endangered or even critically endangered.
Wow. So the data deficient status isn't really a lack of data, it's more like an administrative paralysis, stemming from this scientific debate over how to classify them.
That's a good way to put it, yeah. Recognizing them as separate species triggers specific legal protections, crucial funding under international law. But until that split is formalized globally, some highly threatened groups, like the southern residents off Washington state, don't get the level of international protection they probably need.
Because technically, they're just considered part of a globally abundant species, even though they're clearly struggling.
Exactly.
Yep.
That administrative lag. It's a critical challenge for their conservation.
Okay, let's focus then on the most studied groups, the ones off the west coast of North America, the ecotypes there. There are 3 main types, right? Defined mostly by diet.
Correct. Diet dictates pretty much everything about their lives.
Yeah.
First, you have the residents.
The fish eaters?
Yep, highly social. Their lives revolve around these stable, really complex matrilineal groups. Individuals stay with their mothers for life. It's incredible.
And their strategy involves sound.
Very much so. They're loud, they talk constantly, using echolocation and calls. Because their main prey salmon are relatively deaf to their calls, so they can coordinate hunts acoustically.
Okay, then the counterpoint, the transients, or, as they're often called now, Bigg's orcas.
Right, named after Michael Bigg, the researcher who pioneered photo identification. These are mammal eaters. They hunt seals, sea lions, dolphins, porpoises, even other whales sometimes.
And their strategy is completely different.
Totally different. It's all about stealth. They usually hunt in smaller groups, the bonds aren't quite as rigid as the residents, and critically, they're often silent when hunting.
Because their prey can hear them.
Exactly. Their prey has excellent hearing, so silence is key. The difference in behavior between residents and transients is just, it's so stark. It's hard to believe they're technically the same species right now.
And there's a third group, more mysterious.
The offshores. Yeah, they live further out at sea, as the name suggests. Genetically distinct again. They tend to form really large pods, hundreds sometimes. And their teeth, they're often very worn down.
Disgusting.
Suggesting they might prey heavily on sharks, maybe Greenland sharks or others with rough skin. Or perhaps they feed on schooling fish that require some sort of abrasive processing. We're still learning a lot about the offshores.
And this kind of specialization isn't just a North American thing, right? It's global. You mentioned Antarctic types.
Yes, 4 documented types in the Antarctic alone. Type A, B, C, and D. They have different colorations, slightly different sizes, and definitely different hunting techniques adapted to that icy environment. Type B, for instance, hunts seals on ice floes. Type C hunts fish under the ice.
It just reinforces that idea of multiple species or subspecies.
Absolutely. And the genetic sequencing data strongly supports this. It's not just theory anymore. The data suggests that Antarctic types B and C, plus the North Pacific transients we just talked about, probably should be formally recognized as distinct species.
And there's been some movement on that front recently, a provisional recognition.
Yes, just this year, 2024. The Society for Marine Mammalogy provisionally recognized 2 subspecies for those eastern North Pacific orcas. It's a big step.
What are the new names?
Orcinus orca reader for the residents, and Orcinus orca rectipinus for the transients.
Auroger meaning black, maybe, and rectipinus.
Yeah, Druder likely refers to their dark coloring. Rectipinus probably refers to the transients' generally straighter, taller dorsal fin shape compared to the residents. It's a formal acknowledgement that these groups were on separate evolutionary paths. Huge for science and potentially for conservation down the line.
Okay, let's shift from the species debate to the actual animal. The physical architecture that lets them dominate pretty much every ocean, these are just formidable creatures.
They really are. And the sheer scale is the first thing that hits you. Males are the heavyweights, typically 6 to 8 meters long, that's 20 to 26 feet, and weighing over 6 tons.
6 tons.
Yeah. Females are a bit smaller, usually 5 to 7 meters, maybe 3 to 4 tons. That size difference, the sexual dimorphism, it's quite pronounced.
And nowhere more obvious than that iconic dorsal fin.
Absolutely. The male's dorsal fin is just massive. It can stand up to 1.8 meters high, that's nearly 6 feet, and it's usually shaped like a tall, elongated triangle.
Whereas the females?
Significantly smaller and much more curved, more falcate. You can often spot the adult males in a pod just by that giant fin slicing through the water.
Now, you mentioned photo identification earlier. I found it amazing how scientists use their natural markings like a biological fingerprinting system, right? Crucial for tracking those family bonds.
It completely revolutionized orca science. Being able to identify individuals without having to capture or tag them invasively, it relies on two main things. First, the saddle patch.
That gray or white patch behind the fin.
Exactly. The shape, the color, any markings within it, it's unique to each whale, like a natural name tag.
And the second part.
The dorsal fin itself. Any nicks, scratches, tears, even just the subtle variations in shape over time. These are all cataloged. Researchers use high-resolution photos.
Like a barcode made of scars and shape.
Precisely. And by meticulously tracking these, scientists in the Pacific Northwest, for example, have identified and followed hundreds of individuals over decades, which allows for actual population counts each year, not just estimates.
And that gives incredible insight into their life cycles, who's related to who, how long they live.
It's why we know about matriarchs like Ocean Sun L25, who was estimated to be nearly a century old when she passed. That kind of long-term data comes directly from patiently photographing saddle patches and dorsal fins year after year. A little scratch tells a huge story.
Incredible. And speaking of coloration, it's not always just black and white, is it?
No. Newborn calves, their white areas are actually yellowish or orangey at first. It takes a while to turn bright white. And in the Antarctic, some orcas, especially type B and C, can look distinctly brown or yellow.
Why is that?
It's usually a thick coating of diatoms, microscopic algae, that builds up on their skin in those nutrient-rich but very cold waters. They actually seem to rub against ice sometimes to try and scrape it off.
Huh. Okay, let's talk about their hunting equipment. They're built for speed, obviously, but also for sophisticated detection, right?
Their sensory toolkit is exceptional. They have good eyesight, both above and below water, excellent hearing. But the real game changer is their echolocation. It's incredibly sophisticated.
More than just detecting objects.
Oh, much more. They emit rapid bursts of clicks, and by listening to the returning echoes, they can determine the exact size, shape, location, speed, direction of movement. Even the characteristics of the tissues of their prey, like is it bone or soft tissue. They build a detailed sonic picture of their world.
A 3D sonar map.
Essentially, yes. And then, of course, they need the power to back it up. Those jaws are immensely strong.
And their teeth have that interesting angle, slightly forward.
Yes, the front teeth especially are inclined slightly forward and outward. It's thought to help protect them when prey thrashes violently. It helps brace against those powerful, jerking movements, letting the middle and back teeth maintain the grip without breaking the front ones.
Smart design. And all this is wrapped in a thick layer of blubber. How thick?
It can be 7.6 to 10 centimeters thick, so 3 to 4 inches. Vital insulation for surviving in cold waters, but also energy storage.
And it helps with speed, too, presumably. Streamlining?
Definitely contributes to their hydrodynamics. They're incredibly efficient swimmers. They can reach speeds up to 56 kilometers per hour. That's about 35 miles per hour in short bursts when chasing fast prey or maybe avoiding disturbance. All these physical traits just perfectly equip them as the ocean's apex predator.
Which brings us neatly to their diet and hunting strategies. They get called the wolves of the sea, don't they, because of that cooperative group hunting?
Yeah, that analogy comes up a lot, and it fits in many ways. They need to be effective hunters, too. The average orca needs to eat something like 227 kilograms or 500 pounds of food every single day.
500 pounds. That takes serious teamwork.
It really does. But again, we have to remember the specialization. Different populations, different ecotypes focus on different things. Think about those Northeast Pacific residents again.
The salmon specialists.
Exactly. They've essentially made an existential bet on salmon. Chinook salmon, specifically, make up about 65% of the salmon they eat, and salmon overall is something like 96% of their entire diet.
Which makes them incredibly vulnerable if those salmon stocks decline, right?
Absolutely. It's a direct link. If the Chinook salmon populations crash, which they have, largely due to human factors like habitat loss and overfishing, the southern resident orca population suffers immediately and dramatically. We're seeing that play out right now. Their fate is tied to the salmon's fate.
Such a precarious situation. But other fish-eating populations have developed some amazing techniques, haven't they? Like that carousel feeding off Norway?
Oh, it's incredible to watch. It's used primarily on herring, which form huge schools.
Walk us through it. How does it work?
It's all about coordination. A group of orcas works together to herd a massive school of herring into a tight, dense ball near the surface. They use loud calls, they flash their white undersides, maybe even use bubble nets like humpbacks do, to panic the fish and force them together.
Creating a concentrated bait ball.
Exactly. Once the ball is tightly packed, The orcas don't just charge through it randomly, they take turns. An orca will swim up to the edge of the ball and deliver a powerful slap with its tail flukes.
Just smack
Smack the ball of fish. It creates a shockwave that stuns or kills maybe 10 to 15 herring instantly. Then the orca, and maybe others nearby, just calmly swim through and pick up the stunned, easy-to-eat fish.
Wow. Highly efficient, low-energy way to feed on a huge school. Requires incredible cooperation.
It really does. It's a learned cooperative strategy passed down culturally.
Okay, now let's switch gears to the transients, the mammal eaters. Their prey is a whole different challenge, right? Seals, sea lions, dolphins.
Yeah.
Much smarter, more agile, potentially dangerous.
Absolutely. They hunt a huge variety of marine mammals, and taking down larger prey, like, say, a gray whale calf or even an adult minke whale, requires immense coordination, endurance, and strategy.
How do they manage that?
They often work in groups to isolate a target, frequently a calf, from its mother or the pod. They'll chase it for hours, wearing it down, taking turns to bite at the fins and flukes to slow it down and cause blood loss. It's a relentless, coordinated effort.
And we know some prey species have developed counter strategies, like sperm whales.
Yes. Female sperm whales, when threatened by orcas, will often form a protective circle around their calves, facing outwards with their powerful tails. It's called a rosette or marguerite formation. A wall of flukes is a serious deterrent.
And humpbacks sometimes intervene, even if it's not their own calf being attacked.
That's been observed, yeah. Humpback whales have been seen actively mobbing orcas that are attacking other species, like gray whale calves or even seals. It suggests a level of, well, perhaps empathy or at least a complex understanding of the threat orcas pose across species lines. It's fascinating behavior.
But orcas can even take down the biggest animal on Earth, right? There were those recent records of them killing blue whales.
That was a game changer in understanding their capabilities. Until recently, it was thought adult blue whales were likely immune to orca predation just due to sheer size. But these observations off Western Australia in 2019 and documented fully in 2022.
What did they show?
They documented groups of orcas successfully hunting and killing blue whales, including adults estimated between 18 and 22 meters long. It likely takes dozens of orcas working together for many hours, using coordinated attacks, often targeting the tongue and blubber, causing massive trauma and exhaustion.
It just confirms their status as the ultimate apex predator. Nothing in the ocean is truly safe.
Pretty much. And their interactions with sharks are also really interesting. Great white sharks, for example.
The top predator shark. How do they fare against orcas?
They don't. When orcas show up in an area known for great whites, like the Farallon Islands or South Africa, the sharks typically vanish. They clear out immediately.
So the sharks recognize the orcas as a bigger threat.
Absolutely. Orcas are known to prey on great whites and other sharks like basking sharks, seven gills, rays, and they often show incredible precision, targeting the liver.
Wait, the liver?
It's extremely rich in lipids, very energy dense. They've even developed techniques to sometimes induce tonic immobility in sharks, flipping them upside down to paralyze them to access the liver more easily. It shows this competitive dominance and specialized knowledge.
Okay, now for the really culturally specific learned techniques,
Sure.
Intentional beaching has to be one of the most dramatic.
It is astonishing and incredibly high risk. It's mainly observed in two places, Peninsula Valdez in Argentina and the Crozet Islands in the southern Indian Ocean.
What exactly do they do?
They literally surf a wave onto specific steep, gravelly beaches to grab seals or sea lions resting near the water's edge. Then they have to wriggle back into the water immediately.
Wow. The timing has to be perfect, right? Get stranded and you're done.
Exactly. It's not instinctive. It's a learned skill that takes years to master. And this is where we see clear evidence of teaching.
How so?
In the Crozet Islands, researchers have observed mother orcas deliberately pushing their calves partway onto the beach, sort of nudging them through the motions. They wait nearby, ready to pull the calf back if it gets stuck. Sometimes they'll even bring a stunned or weakened seal for the calf to practice on.
That's incredible, deliberate, risky teaching of a complex skill, passing down culture.
It's one of the clearest examples of animal teaching outside of primates. Truly remarkable.
And the wave washing in Antarctica is just as clever, using physics.
Right. This is primarily Antarctic type B orcas hunting seals, like Weddell seals, resting on ice floes.
So how does the wave thing work?
First, they often spy hop, lifting their heads vertically out of the water to locate a seal on a floe, maybe quite far away. Then a group of them, maybe 4 or 5, will line up side by side.
Okay.
And they swim together in perfect synchrony, building speed directly towards the ice flow. They create a coordinated underwater surge, a bow wave.
A targeted mini tsunami.
Exactly. The wave washes over the floe, washing the seal off the ice and into the water.
Where other members of the pod are waiting.
Precisely. Other orcas are often positioned strategically to intercept the seal as soon as it hits the water. It's an incredibly calculated, cooperative maneuver using hydrodynamics, pure genius and learned culture combined.
Amazing. Before we move off hunting, we should touch on a couple of stranger behaviors mentioned in the sources. Surplus killing.
Yeah, there are observations, like off British Columbia with stellar sea lions, where orcas seem to, well, play with their prey until it's exhausted and dies, but then they don't actually eat it.
Why would they do that? Practice. Play.
We don't fully know the motivation. Maybe hunting practice for younger animals, maybe a form of social bonding or play, maybe just an expression of their high intelligence and capability when food isn't scarce. It's puzzling.
And the salmon hats.
Slight chuckle.
Yeah, that's another odd one, primarily seen in the southern residents. Orcas, especially females, have been seen carrying dead salmon balanced on their heads for extended periods. Looks like they're wearing a hat.
Any idea why? Honestly, no clear explanation. It seems to be a behavioral fad that pops up, spreads through the group for a while, and then fades away. It might be play. It might have some social significance we don't grasp. It's definitely learned and passed around, another little piece of their culture.
Okay, so the complexity of their hunting is clearly immense, and it seems matched only by the complexity of their minds and, crucially, their societies. Let's get into that social architecture.
This really is the cornerstone of understanding the orca. Their societies are incredibly complex, incredibly stable. The only real comparisons in the mammal world are elephants and maybe some higher primates.
And understanding this complexity is vital for debates like the one around captivity, right?
Absolutely. Because when you capture an orca, you're not just taking an individual animal, you're potentially removing a key member from a highly integrated, long-lasting social unit, a civilization in a sense. The impacts ripple through the whole group.
And the absolute core of that resident society is the matriline. Tell us about the stability there. It's extraordinary.
It really is unmatched by most mammals. In resident populations particularly, individuals of both sexes live with their mothers for their entire lives.
Whole lives, never leaving.
Never permanently leaving the core matrilineal group. A female, a matriarch, can live up to 90 years. So you can have pods traveling together that span 4 generations. The old matriarch, her sons and daughters, her daughter's offspring, maybe even their offspring.
Wow. And they only separate briefly.
Yeah, maybe for a few hours at a time for foraging in smaller groups, or for mating, which happens outside the pod. But they always return to that core family unit.
That lifelong bond must make the older females incredibly important, especially given that orcas are one of the few species, besides humans and pilot whales, known to go through menopause.
Exactly. The post-reproductive matriarch isn't just retired. She becomes this vital reservoir of ecological knowledge and social leadership.
Like knowing where to find food during lean years.
Precisely. She knows the migration routes, the best hunting spots learned over decades, which other pods are related or friendly. This supports the grandmother hypothesis, the idea that older, non-reproductive females significantly boost the survival chances of their younger kin by sharing crucial knowledge and experience.
That's fascinating. And the mating system reinforces this. They mate outside their own group.
Yes, they practice exogamy mating outside the immediate pod or clan, which is crucial for maintaining genetic diversity and preventing inbreeding. But the offspring always belong to the mother's matriline. They come home.
So it maintains the family unit's integrity while ensuring genetic health. Smart system. But this structure isn't just one layer, is it? Matrilines grouped together.
Right. There's a clear hierarchy, especially among residents. You have the core matriline. Then several related matrilines that frequently travel and socialize together form a pod. Pods are often the units we study most closely.
And beyond pods.
You have clans. Clans are groups of pods that share similar acoustic dialects and likely descend from a common older maternal ancestor, even if the direct link is generations back.
So the way they talk reflects their shared history.
Exactly. Similarity in dialect indicates closeness and relatedness, culturally and genetically. And then the broadest level is the community. This is a collection of pods that regularly associate, maybe in specific seasons or areas, but they don't necessarily share dialects or recent maternal ancestors. It's the larger social network where mating between different clans likely occurs.
Okay, so these layers are reflected in their communication. Let's talk about their vocalizations. Clicks, whistles, pulsed calls.
Right. Clicks are primarily for echolocation, for navigating and finding prey. Whistles and the complex pulsed calls are more for social communication.
And the dialects are key cultural markers.
Absolutely. Each resident pod has its own unique, stable dialect, a specific repertoire of discrete, repetitive pulsed calls. These are learned, passed down through generations, primarily from mother to calf.
So a calf learns its family accent.
Pretty much, yeah. And the degree of similarity between the dialects of different pods reflects how closely related those pods are. It's a badge of identity and relatedness.
And this links back to that difference between residents and transients, right? The acoustic strategy.
Crucial difference. It's adaptive communication. Residents, hunting fish that don't hear their calls well, can afford to be incredibly vocal. They're constantly chatting, coordinating hunts, socializing.
Whereas transients hunting mammals
Have to be silent assassins. Their prey seals, dolphins have excellent hearing, often in the same frequencies orcas use. So transients are typically very quiet when hunting, relying on stealth and maybe passive listening more than active echolocation. This silence is a vital, learned cultural strategy for survival. Newborns learn their calls from their mothers, reinforcing that this is culturally transmitted from the start.
Okay, let's shift to intelligence itself. We know they have big brains, but what's the evidence beyond just size?
Well, size isn't everything, but
Right.
they do have the second heaviest brain among all marine mammals. Only sperm whales have bigger ones. But more importantly, studies show a very large and complex cerebrum. They have possibly more gray matter and a higher density of cortical neurons in certain areas than almost any other mammal, potentially including humans.
So the hardware for complex thought is definitely there.
It certainly seems so. And this neurological capacity translates directly into the complex problem-solving, learning, and cognitive flexibility we see in their behavior.
Like that famous story about the Alaskan orcas and the long-line fishing boats. That really shows adaptation, doesn't it?
It's a classic example of their cognitive flexibility. Fishermen started using long lines, and the orcas quickly figured out, hey, free meal. They learned to patrol the lines and steal the fish, often just stripping the valuable parts.
So the fishermen tried to trick them.
Yeah, they tried using decoy lines with no bait, hoping the orcas would waste time checking them. But the orcas quickly learned to distinguish the real lines from the fakes, probably by acoustics or subtle visual cues.
Then the fishermen tried spacing their boats far apart, pulling up only small amounts of fish at a time, trying to overwhelm the orcas.
Right, thinking one pod couldn't be everywhere at once. But the orcas adapted again. They learned to split their pods into coordinated groups. One group would shadow one boat, another group would shadow the second boat miles away, defeating the fishermen's strategy.
They were essentially coordinating a counter strategy across multiple locations.
Exactly. It shows sophisticated problem-solving, communication, and learning being passed between individuals and groups in response to a human challenge. Remarkable stuff.
But perhaps the biggest news, something that really challenges definitions, came just this year, 2025. The tool use observation.
Ah, yes, the allokelping. That was extraordinary. Observed in the Salish Sea, near where the southern residents live.
What exactly was seen?
An orca, and maybe others later, was filmed deliberately tearing off long strands of bull kelp, and then, well, rolling them around its body, draping them over itself, sometimes in groups.
Okay, why is that considered tool use? It sounds a bit like play, or maybe decoration.
And that's the fascinating part. Even if the purpose is play, or maybe sensory exploration or social display, we don't know the purpose for sure. It represents the deliberate modification and manipulation of an external object for a specific interaction.
Using something from the environment as an extension of oneself.
Exactly. It's the first properly documented case of tool use, however you define the edges of that term, in wild killer whales. It demonstrates that the cognitive capacity to interact with objects in this complex, non-essential way exists in their world.
It forces us to broaden our definition of what constitutes tools or technology in the non-human world, doesn't it?
It absolutely does. It opens up a whole new avenue for research and understanding their cognitive world.
And beyond problem solving and tools, there are anecdotes suggesting, well, almost a sense of humor or playful teasing.
Researchers have certainly described behaviors that are hard to interpret otherwise. Things like wild orcas repeatedly moving equipment, like hydrophones, just out of reach when divers try to retrieve them, or initiating interactions that seem like games.
Like the snowball story.
Yeah, there's an account from Antarctica where a researcher threw a snowball into the water near an orca, and the orca dove down, came back up with a chunk of ice, and tossed it back towards the boat. It's hard not to see that as playful interaction, a sign of curiosity, and high social intelligence.
Okay, let's look at their life cycle and the big conservation issues threatening these incredibly intelligent cultural beings. We mentioned the long lives of females, the matriarchs being critical, especially with menopause. Females can live 50 to 80 years, typically, some close to 100.
That's right. Ocean sun, L25, was estimated to be around 97. That long post-reproductive life is key for passing down knowledge. Males, though, have a significantly shorter average lifespan.
How much shorter?
Average is around 29 years, maybe a maximum of 60 in the wild. And studies suggest they remain quite dependent on their mothers or other females in the pod for successful foraging and survival throughout their lives. Losing a matriarch can be devastating for her sons especially.
Now, despite being found globally, they face serious threats. And maybe the biggest, most insidious one is pollution, especially toxins like PCBs.
Yes, this is where that data-deficient IUCN status becomes problematic again, because it masks severe localized threats. The most critical global threat is likely the bioaccumulation of legacy industrial chemicals, particularly polychlorinated biphenyls, PCBs, and also some persistent pesticides like DDT.
Why are orcas so vulnerable to these? How does it work up the food chain?
It's a process called biomagnification. PCBs are fat-soluble, meaning they accumulate in fatty tissues. Tiny organisms absorb a little bit. Small fish eat lots of those organisms, concentrating the PCBs. Bigger fish, like salmon, eat lots of smaller fish, concentrating it further.
And the orca's at the very top.
Exactly, eating hundreds of pounds of contaminated fish every single day. So the orca accumulates the toxic load from everything below it in the food web, concentrating these chemicals to incredibly high levels in its own blubber.
And what do these high PCB levels do to the orcas?
They're devastating. They severely disrupt reproductive function, leading to miscarriages, stillbirths, and very high calf mortality in the first year. They also fundamentally compromise the immune system, making the orcas much more vulnerable to diseases.
So it hits them on multiple fronts.
Yes. A major study in 2018 projected a dramatic decline, even collapse, of many orca populations around the world in the coming decades, purely due to the existing levels of PCB pollution. It's a toxic time bomb they carry in their bodies.
That's incredibly grim. And on top of chemical pollution, there's noise pollution. Shipping, drilling, sonar.
Yeah, underwater noise is a huge problem. Chronic noise from shipping traffic masks their communication calls and interferes with their echolocation, making it harder to hunt and socialize. This is especially true in critical habitats like Haro Strait for the southern residents.
And acute high intensity sounds like Navy sonar. That can cause physical harm, right? Not just stress.
There's strong evidence for that. High-intensity, mid-frequency active sonar, used by navies for submarine detection, overlaps with frequencies orcas use and hear well. Research on other cetaceans, like beaked whales, has linked sonar exposure to strandings and tissues damage consistent with decompression sickness, the bends.
The idea being the sonar panics them, causing them to surface too rapidly.
That's a leading hypothesis. Researcher Ken Balcom documented unusual agitation, grouping, and movement away from sonar activity in orcas in Puget Sound back in 2003. It strongly suggests sonar can cause significant disturbance, potentially leading to injury or even death. It shows how our acoustic footprint is making their world dangerous.
Okay, let's pivot slightly to how our perception of them has changed. It really flipped from fear to fascination, didn't it? And Moby Doll in 1964 seems to be the catalyst.
Moby Doll was huge. Captured off British Columbia, initially intended to be killed and used as a model for a sculpture. But the aquarium director decided to try and keep him alive. He became the first orca ever studied closely in captivity.
And what did they find? The savage flesh.
The complete opposite. To everyone's surprise, Moby Doll was remarkably docile, intelligent, and showed no aggression towards his human keepers. It completely shattered the killer myth for the public and scientists alike. It sparked this huge wave of interest and research in live orcas that really took off through the 1970s.
But that shift also led directly to the rise of orcas in marine parks and the whole controversy around captivity.
Exactly. It's a complex legacy. Public fascination fueled the demand for seeing them up close. But ethically, it's deeply problematic. We know wild lifespans are much longer. Females averaging maybe 46 years, living up to 80. Males averaging 31, maxing out around 60.
Compared to captive lifespans.
Much shorter on average, often only in their 20s historically.
Yeah.
Plus, you see health issues rarely seen in the wild, like the dorsal fin collapse in 60 to 90% of captive males, likely due to gravity, swimming in circles in shallow tanks, maybe diet and stress too.
And critically, the history of attacks on trainers in captivity, like Tilikum, involved in multiple deaths.
Right. which stands in stark contrast to the fact that there has never been a single, reliably documented case of a wild orca killing a human. Never.
That difference really highlights the argument that their intelligence, their social needs, their sheer size and power make them fundamentally unsuited to life in a concrete tank.
That's the core ethical argument. The film, Blackfish, brought this to a massive audience, and certainly pressured places like SeaWorld to end their orca breeding programs in 2016. Those shows continue. The debate is far from over.
And finally, the most recent and perhaps strangest human-orca interaction, the Iberian situation. Since 2020, these coordinated attacks on sailboats.
It's unprecedented and bizarre. We're talking over 500 incidents reported between 2020 and 2023 off the coasts of Spain and Portugal, primarily sailboats.
And they're specifically targeting
the rudders. Videos and accounts show groups of orcas, often younger ones but sometimes adults too, deliberately ramming, biting, and pushing on the rudders, sometimes snapping them clean off. They seem focused entirely on disabling the steering mechanism.
Why? What are the theories? Experts seem completely divided.
They really are. Theories range wildly. Could it be some kind of revenge for a past negative interaction, maybe involving entanglement or a boat strike, initiated by one individual nicknamed White Gladys, and spreading culturally?
Or something less intentional?
Maybe. Some suggest it could be related to interacting with the propeller wash or the boat's wake, maybe a behavior that started as play or curiosity and escalated. Or perhaps it's truly just play. A behavioral fad, like the salmon hats, that got rougher and is spreading through this specific subpopulation. Right now, the play or cultural fad theory seems to be gaining traction, given it's mostly non-aggressive towards humans themselves and localized.
And the recommended defense is almost as strange as the attacks themselves. Dropping sandbags.
Yeah, the advice from some authorities is to try and disrupt their focus or potentially confuse their sonar by dropping bags of sand or make noise underwater near the rudder area. It shows how much we're still scrambling to understand and respond to this completely novel learned behavior in an intelligent adaptive predator.
Wow. Okay, so this deep dive has shown, I think, beyond any doubt, that the orca isn't just one thing. It's not monolithic. It's this collection of distinct culturally rich populations, specialized hunters, complex social bonds, rivaling our own in some ways.
Absolutely. We've unpacked the species problem, how that data-deficient label hides real conservation crises. We looked at the incredible adaptations for hunting, the sheer variety from carousel feeding on herring to wave-washing seals off ice.
And the foundation of it all. Those incredibly stable matrilineal societies where knowledge held by post-reproductive grandmothers is absolutely key. The capacity for teaching high-risk behaviors like intentional beaching. It's just mind-blowing.
And then, just this year, documented tool use with the allokelping. It just keeps pushing our understanding of their cognitive ability.
But layered on top of all that wonder are these immense challenges they face. The PCBs ticking away in their blubber, threatening their ability to even reproduce successfully. The constant barrage of underwater noise. These strange new conflicts with boats.
And these are almost entirely human-caused pressures, impacting these incredibly specialized ocean-spanning civilizations that we're only just beginning to truly appreciate.
So, wrapping this up for you, our listener, what does it all mean? The sources show orcas passing down hunting skills generationally, maintaining these rigid social structures, maybe even using tools now. What responsibility does that place on us? Especially when we once just saw them as savage flesh.
Yeah. How do we grapple with a non-human species that clearly possesses culture, actively teaches it, and forces us to rethink intelligence itself? What other complex cultural practices, these unique oceanic ways of life, are out there, maybe disappearing before we even get a chance to understand them?
That really is the crucial question, isn't it?
It is. We've barely scratched the surface of understanding how these diverse orca societies function, how they communicate, how they see the world. We need to move fast, scientifically to understand and politically to protect their distinct identities and cultures before the very complexity we're learning to admire is lost forever under the weight of human impact.
A powerful and challenging thought to end on. Thank you for diving deep with us today into the world of the orca. We'll see you next time on The Deep Dive.